What's up YouTube, and welcome to another math lesson from Last Minute Math. Today we are going to talk about function notation. First off, you may ask, what is function notation? Well, it sounds complicated at first, but it's actually extremely simple. At first glance, it is simply another way of representing the value of the dependent variable for any given independent variable. In short, instead of writing something like y equals x squared, it is f of x equals x squared. As explained prior, for any input of x, we simply solve the equation for f of x, and this gives us the output, the y value. Okay, let's start off with a simple example. Let's say we are given the function g of t equals 3t plus 5. What is g of 3? So first of all, what does g of 3 mean? Remember, 3t plus 5 is equal to g of t, meaning that for g of 3, t is equal to 3. As a result, all we have to do is substitute 3 for t. So let's do that. So as a result, we now know that g of 3 is equal to 14. Next, let's go into a slightly different example. How about g of 1001 minus g of 1000? As we did in the last example, we are going to substitute 1001 for t for our first term, meaning that we have 3 times 1001 plus 5. And then for a second term, we're going to replace t with 1000. So 3 of 1000 plus 5. However, there's one thing wrong here. It's that since we have minus g of 1000, we have to put everything here in brackets. 3 times 1000 plus 5. Everything there has to be in brackets because g of 1000 is a term by itself, meaning that we multiply all the terms inside g of 1000 by -1. So now we're going to solve that. 3003 plus 5 minus, in brackets, 3000 plus 5. Okay, so I guess that gives us 3008 minus 3005, giving us, at the end, 3. Therefore, g of 1001 minus g of 1000 is equal to 3. Okay, great. Now that we've got the knowledge out of the way, let's go on to a significant word problem. Let's say we have a parabolic bridge above the river. If you don't know what a parabola is, it is a U-shaped, symmetrical shape used to display a relation, like we have right over here. Let's say the feet of the arches are 281 meters apart, that means the bottom point's here, and the top of the arch rises 71 meters above the river. That means the highest point rises 71 meters above the river. It's also cool to note that the top of the arch is directly in the middle of the 2 feet. So what is a function that models this arc? First off, how are we going to write a function modeling this parabola? Well, it's a combination of multiple different steps. First, we're going to draw a slightly accurate model of this function's graph, as we already have done here. The next thing we are going to do is to imagine this parabola has its feet on the x-axis, exactly the same distance from the origin, which is right here in the middle, 0, 0. This means that one of the feet will be at negative 140.5 and 0, and the other will be at 140.5 and 0. This is because the feet of the arches are 281 meters apart, so if they're exactly the same distance from the origin, their placement would be 281 divided by 2, and then we would have one on the negative side and one on the positive side. Also, they're on the x-axis, meaning the y value would always be 0. Since this parabola is facing down and has a height of 71 meters above the river, which is the x-axis in this drawing, this means that the vertex must be at 0 and 71. This is because the top of the arch is directly in the middle of the 2 feet, meaning that the x value would be 0, and the bridge rises 71 meters above the river. This means that it must be at the point 0 and 71. Now with this information, we can substitute our two x-intercepts, negative 140.5 and 140.5, into the equation f of x equals a times x minus r times x minus s. This is the equation that you use to find a function when we are given 3 points where 2 of them are the x-intercepts. So in this case, a would be the vertical stretch or vertical compression, and then r and s would be the x-intercepts. So let's substitute our x-intercepts into this equation. That would give us f of x is equal to a times x plus 140.5 times x minus 140.5. So now what are we going to do? We're going to substitute our last point here, 0 and 71. So that would give us f of x, which is 71, is equal to a times 0 plus 140.5, that's 140.5, times 0 minus 140.5, which is negative 140.5. So that would give us negative 19,740.25 a. Okay, now we can move this number over here to the other side, isolating for a. So a would be equal to negative 285 over 78,961. As a result, all we have to do now is put a back into the equation that we've already have. So that would give us f of x is equal to a, which is negative 285 over 78,961 multiplied by x plus 140.5, and then multiplied by x minus 140.5. As a result, this gives us the final function that models this arc over here. Thank you so much for joining me for another awesome last-minute math lesson. If you love this lesson, make sure to like this video, subscribe, and share this video to anyone you know who may be in need. See you next time.